Okay, we are going to start a brand new chapter with this handout today. I want to start off by saying that it's actually chapter 10-1 in your textbook. So if you want to read that section before doing this, it's a good idea. You're going to find it a bit more familiar than the ellipses or even the circles. So if you can print this out, great. Print it out and do it. If you can't, just do it on notebook paper, take a picture, turn it in. Okay, so it's two sides. The first side I'm starting on says arithmetic sequences. Make sure that you're on the correct side. The second side is titled geometric sequences. Some of you might remember this from Algebra 1. It's okay if you don't. So, an arithmetic sequence is a sequence of numbers in which each term is found by adding a common difference to the preceding term. So, it's called arithmetic, and that's because it uses arithmetic. So, arithmetic is a noun, and arithmetic, pronounced that way, is an adjective. So, that's why I'm saying it that way. Okay. So a sequence is a list of numbers. An arithmetic sequence is a list of numbers that, make sure this is in there, that has an adding or subtracting pattern. Okay, so this fancy definition just means a list of numbers that has an adding or subtracting pattern. So looking at this first example, they tell you it's an arithmetic sequence, and here's the list. So it says find the next four terms, so I can see that this is going up. 7 to 11 goes up 4, 11 to 15 goes up 4. So my next four terms, I'll just add 4 to get 19, add 4 to get 23, add 4 to get 27, add 4 to get 31. So that's easy enough. Find the pattern, continue the pattern. The next part that you probably did not really cover in Algebra 1 would be graphing. So to graph this on a coordinate plane, you want to look at the list and realize that these are y values of ordered pairs, and that the number that they are on the list would be an x value in the ordered pair. So this first point is 7. That corresponds to the ordered pair 1, 7. And then the next ordered pair you graph is 2, 11, and then 3, 15, 4, 19, 5, 23, 6, 27, and 7, 31. So that's what's happened here. This is 1, 7, 2, 11. You can see that any and all arithmetic sequences have a linear relationship. Meaning they make a straight line. So this is a straight line, but do not connect the points. Connect. Because we aren't graphing a linear function or an equation here, what we're graphing is a list of numbers. And so we just keep these separate, just like this. Do not connect the points when you're graphing sequences. Okay, so you're gonna go ahead and do these next 6. I guess I'll do number 1 and 2, and let you do the rest. So find the next 4 terms of the arithmetic sequence, then graph. So I need to figure out the pattern. 106 to 111 is going up 5. Guess I should do a subtraction one. So I'm just gonna add 5 to get to the next one. So we got what, 121, 126, 131, 136. So when we graph, our ordered pairs are going to be 1, 106, 2, 111, 3, 116, 4, 121, 5, 126, 6, 131, 7, 136. And if you need a separate paper, of course, do a separate paper. All right, so this looks a little tricky. My x's are going to go by ones and my y's are done for me. So 1, 106. 2, 111. 3, 116. 4, 121. 5, 126. 6, 131. 7. All right, resist the urge to connect your points. That is done. Okay, I'm now going to skip to number, I'm going to do number 3, and then, all right, I'm going to skip over to number 3, and I'm going to look and see how these numbers are changing. They look to be going down, so I'm going to think, well, how much are they going down by? Looks like they're going down 13. So I'm going to continue the pattern. 181 minus 13. 168 minus 13. 155 minus 13, and 142 minus 13. And then I'm going to graph those points. So these represent ordered pairs in the sequence. Okay, and since it's going down, you see that this has like a negative slope. That's correct. If your common difference is going down, your line should be going down. So if I hadn't already said it, the number that the sequence is changing by, like in number 1 it's +5, and in here it's down 13, that's called a common difference. And you can find that vocabulary word here. Okay, so you guys go ahead and finish these. I'm going to go on to the other side, geometric sequences. Geometric sequences are a bit more fun because they follow a different pattern. They follow a multiplication pattern where each term has a common ratio. So you find the ratio by dividing the second term by the first term. The common ratio is a geometric sequence with consecutive terms. So if this was your sequence, you would do 10 divided by 5 is 2. Let's look at our first example. Find the next 3 terms of the geometric sequence, and here's the numbers. You can see that they're not going up consistently, like they're not adding. This is +4 and this is +12. So it's not adding. So then you think, well, is there another pattern here? Well, 2 times 3 is 6, and 6 times 3 is 18. So this is being multiplied by 3. So if I couldn't figure it out, what I would do, I would find the common ratio by dividing the two consecutive terms. So like this says, it's the second term divided by the first term, the third term divided by the second term, and they all gave us the value of 3. So we want to do, it says find the next 3 terms. 18 times 3 is going to be 54. 54 times 3 and 162 times 3 maybe 486. Let me just check that. Okay, so here's our list, and we're gonna graph this sequence. So I like how they put it here on this side of the worksheet. It says to find the domain and range for the next 6 terms. So like I said before, the x values are the number that the term is in each list. So for our first ordered pair, it would be 1, 2, and then 2, 6, and then 3, 18, and 4, 54, 5, 162, and 6, 486. So remember that the x value is the number that it is in the list, and then the y value is the actual term. So here it's really nice in the notes. They call the number the domain and the term the range. So that's nice. Okay. So that's kind of an SAT type question. Given a sequence, what would the domain be? So keep that in mind. So if you look at the graph, it's already done here for you. This is not a linear graph. This has an exponential curve to it. Let me just see how I worded this. All arithmetic sequences have a linear relationship. Geometric sequences have an exponential relationship. Exponential. And exponential functions we worked on maybe December or January. And remember that exponential graphs, they start low and they go up very high. This is when we talked about a paper being folded so many times you could reach the moon. That must have been January. So it starts low and goes high, or just the opposite, starts high and goes low. So that's what these geometric sequences are going to look like when you graph them. They're like a half curve. All right, so looking at this first example, it's kind of tricky to figure out how each number is changing. So if you can't just see it, the process of figuring out what the common ratio is, that's R, to find R common ratio, divide second term by first term. So I'm going to do 1/4 over 1/16, and I'm going to do 1 divided by 1/4, the third divided by the second term. So what is 1/4 divided by 1/16? Well, we don't divide fractions. We multiply by the reciprocal. So remember, complex fractions can just be written, instead of vertically, horizontally. So this is really 1/4 times 16 over 1, which is 16 over 4, which is 4. Can you see that tiny writing? So that leads me to believe that r is 4. So I'll look at the second set of numbers, 1 over 1/4. 1 divided by 1/4 is 1 times 4 over 1, which is 4. So again, r is 4. So kind of hard to see that this is being multiplied by 4, but 1/16 times 4 is 1/4. And 1/4 times 4 is 1. So we're going to multiply 4 here. 1 times 4 is 4. 4 times 4 is 16. And 16 times 4 is 64. So those are our next three terms. So when I graph, my ordered pairs are 1, 1/16, 2, 1/4, 3, 1, 4, 4, 5, 16, and 6, 64. So I'm going to go by ones on the x-axis. 1 and 1/16 is just about at 0, which, if you remember, always happened to us with these exponential graphs. 2 1/4 is not really any further. Even 3 1, not much further. 4 4, not even halfway. Finally, 5 16. And then 6 64, and that's the nature of exponential functions. They start slow, and then they jump up very quickly. If you remember, we talked about exponential growth and investing money. We also talked about how bacteria grows and how, like when you have a cold, this is when I was really sick in February. When you have a cold, the bacteria grows quickly, and then by the end of the day, you have all this bacteria in your mouth, and that's what makes your nose so runny. So that's exponential growth. Okay, so here in number, oh, you know what, you guys? Make sure you don't connect the points here. I got lost. And I did it in pen because I'm trying to do this darker for the video, but you guys, if you connected these dots, go back and erase it. I'm really sorry, do not do that. Hopefully this helps you remember not to do it, seeing someone do it wrong. Okay. On the next one, the common ratio is actually 1/5 because 20 times 1/5 is 4, and 4 times 1/5 is 4/5. So you're gonna multiply 1/5 here to get 4 over 25, and then you multiply 1/5 again to get 4 over 125, and then you multiply 1/5 again to get 4 over, what is that, 625? Yes. So when you're graphing this, it's going to be really tricky. We're going to go 1, 20, 2, 4, 3, 4/5, which is just over, just under 1. And then 4 25ths, 4 1/25. So I'm just getting really close to 0. And I'm going to resist the urge to connect the points. Don't connect the points. I'm really sorry I did that in the first one. All right, I'm going to leave this third one to you. Notice all the values are negative. They're going to stay negative. Find the common ratio. Looks like it's a fraction. And let me know if you have any questions. Thanks.